Hello everyone, and welcome to the Tree Methods Code Along lecture, where we're going to be coding through a custom example. What we're going to be doing is working through all three tree methods discussed and compare their results on a college dataset. The dataset has features of universities, and the universities are labeled either a private university or a public university. And we're going to use the different tree methods to attempt to label or build a model that can predict whether a university based off its features is private or public. Let's jump to a new notebook and get started. Okay, here I am at a new notebook, and the college data set that we're going to be working with is available for you underneath the Tree Methods folder underneath Spark for Machine Learning, and it's called college.csv. But before we get started with that, let's start a PySpark session, or a Spark session I should say, and then we'll import Spark session from PySpark.sql, and we'll create Spark is equal to Spark session builder, and give the app name, you can call it whatever you want. I'll call it tree, and then we will get or create this Spark session. Now the next thing we want to do is actually load in that training data. So as we've done before, since it's just a CSV file, I'll say read CSV, and it's called college.csv, and you can always use tab to autocomplete and confirm that. And we'll say infer schema is true, as well as header to be true. So once we've run that, and once the data is loaded, we're going to print the schema, just so we can get an idea of what the data looks like. Once we've printed the schema, you can see here the various columns, and if you want definitions or descriptions for each of these columns, you can just check out the Code Along lecture, and it has descriptions for each of these. But essentially what these are, they're just features of the schools. So you have the school name, then you have whether or not it's private, which is what we're going to be trying to predict, and then a whole bunch of features about it. Things such as the number of applications received, number of new students enrolled, what percentage of new students come from the top 10% of the high school class, or the top 25%, as we see here, etc. The out-of-state tuition. So if you want an example of what this actually looks like, you can just say head 1, and then check out the actual data itself. So you can see here we have this first school. Yes, it's a private university, the number of applications, the percent of alumni who donate back to the school, etc. So what we're going to be doing is testing out the various tree methods on this. So let's actually start formatting this data. There's a lot of columns to format. So we'll say from pyspark.ml.feature import vector assembler. So I'm going to import that, and then I'm also going to call for the columns themselves to save myself some typing when I actually pass the feature columns into vector assembler. So let's build this out now. I will say assembler is equal to this vector assembler as we've done in the past, and then I need to grab the input columns. I'll set that as an empty list right now, and I also want to grab the output column, or just define the output column as features. So what we need is the actual features that we're going to be using, and we're going to be using basically everything below the school's name and whether or not it's private. So everything from apps all the way to the graduation rate works for us. So I'm going to copy this and then paste it in here, and let me make sure everything's balanced. That should work for us, so let's try this. Run that, make sure we don't get any errors. Okay, so far it's all looking good. We'll continue on and actually create the output. I will say output is equal to that assembler, and then I will transform the data. Run that, and you shouldn't get any errors there. Okay, now we want to deal with the private column. So if you take a look at the actual output, so if we come back up here, remember that this private column is what we're trying to predict, but right now we have the issue that it's a string. It says either yes or no. So we need to actually change that to a 0 or 1 because Spark's MLlib library can't deal with a yes or no directly. So we'll come back down here, and we're going to say from pyspark.ml.feature import a string indexer, and then run that. And then we'll say indexer is string indexer. The input column I'm expecting just says private, and the output column I'm going to create will just be something very similar, maybe private index. And then I want the output underscore fixed to be equal to that indexer object dot fit, and then I'm going to fit the output and then transform the output. So I'm doing this all in one step. If you want to, you can actually split this up into 2 steps. We've seen it split before, And this is just what it looks like all in one step. And you could also use a pipeline if you wanted to. If you had to do this for a lot more features for various string indexers, I definitely suggest you use a pipeline. But if there's just one column, just a single column you have to apply string indexer to, it's okay to not use a pipeline. It's really up to you. And what pipelines are really for is if you're going to repeat your code a lot. That's when you have to really consider the pipeline. Right now, this is kind of just a code along, so we're fine just doing it this way. And then finally, what I'm going to do is I have my output fixed. Let's check what that looks like. I'm going to say print the schema of this, run that. So I have school, private, still as a string. If I scroll all the way down, I see features. Great, that's a vector that I created. And then private index, it's the double that I created. So everything's looking good. I really just need these two columns, but we can pass them all if we really wanted to. And what we're going to do is say my final data is equal to output fixed, and then just those two columns that I just mentioned. Features, and then private index as a string. Private index. So let's run that. And now I want to split this into some training data and some test data. So I will say final data, call random split on it, and as we've done before, let's just do 0.7 and 0.3. Run that. So now we have our training data and our test data. And it's time to actually check out the different classification methods I could use. I could use the decision tree classifier, the gradient boosted tree classifier, or the random forest classifier. So since we're using the tree methods for classification, I need to say pyspark.ml and then call classification here. Then I can call decision tree classifier. I can also then call, if you start typing GB, there's a GBT classifier. And then there's also if you start typing random, let me put this on a new line. Whoops, let's put this in parentheses, that way we can do multiple lines here. And then the final one, if we tab this over, is going to be called random forest classifier. So that's random forest classifier. So let's run those. Now you can use tree methods, as I mentioned earlier, for regression tasks. So you could say from pyspark.ml.regression and then begin exploring some of these regressions. So if you start typing in random, there is a random forest regressor that you could use. And again, the difference is, as we noted in the theory lecture, these random forest classifiers, or tree method classifiers in general, essentially are just voting for what class they think the actual sample belongs to. For regressor, if you have a bunch of trees versus just a single tree, what the regressor will do is all the trees will give their estimate of what they think the continuous value should be, and then you just average all of those, and that's the random forest regressor. Right now we're just doing classification. Classification is kind of easier to explore as far as evaluation, just because it becomes really clear what accuracy, precision, and recall mean, how many you got right, how many you got wrong, versus checking something out like the root mean squared error. But either way, just keep in mind, all of these can also be used for regression, as long as they're available for you under pyspark.ml.regression. And let's actually show off how to use the pipeline a little more. So we'll say import pipeline from pyspark.ml. Okay, so I'm going to create 3 different models here. DTC, that's going to stand for my decision tree classifier, and this is going to have the label column of private index, and then my features column is going to be just called features. And essentially these are all going to be the same. So I will say RFC is equal to my random forest classifier, and I'm going to pass in the exact same arguments. So label column, features column. Copy those and then paste them in. And then I'm also going to say GBT for gradient boosted trees. That's going to be my gradient boosted classifier, and then copy and paste that in. And hopefully by now this feels super familiar to you, and you realize just how easy it is to swap classifiers or any different models in and out using Python and Spark. So we want to train all of these models. So we'll say DTC model is equal to DTC, and I will fit this to my training data, and I will do the exact same thing for the rest of them. So I'll create the model object that's going to be fitted, again, to my training data. One more, we'll say GBT model, and it says RFC fit to, GBT, not RFC, excuse me, GBT fit to the train data. Perfect. So we'll run all of those. That may take a little bit of time because it's fitting 3 different models just in a single cell. So you're going to let it run for just a little bit. And what we're going to do in the meantime is check out the model comparison. So the model comparison is going to look really similar to this. We're essentially going to transform for all of these. So we'll say DTC preds for predictions is equal to DTC underscore model. And I'm going to then transform my test data. And I'm going to do a really similar thing to the rest of them. So let's just copy and paste this so we can add it in later. I'm going to say RFC preds is equal to RFC and then paste the rest of that. And then we'll do the same thing for gradient boosted trees. So my gradient boosted tree predictions is equal to GBT and then copy and paste the model. So we'll run that as well. Again, that may take a little bit of time. The transform process, however, should be pretty quick. The fitting is what takes a long time with models. So now let's get some evaluation metrics and actually see how all of these did. So we'll say from PySpark.ml.evaluation, we're going to import the binary classification evaluator. So once we've imported that binary classification evaluator, I can create my evaluation object. We'll call this and I'm actually going to call this my binary eval. And then I will set this equal to an instance of that binary classification evaluator. And if you hit Shift Tab, remember the arguments are raw prediction column and label column. Right now my label column is not called label, it's called private index. So I want to clarify that. I'll say label column is the private index. And we'll just go ahead and feed it that raw prediction column, that's fine. And now it's time to evaluate each of these models. So let's print out a little line for us. So we'll say DTC for the decision tree classifier. And then what I'm going to do is print out the result of my binary eval. And then I will evaluate the results of the actual predictions, which was DTC underscore preds. So let's run this and see the results. Okay, so this is the area under the curve, 0.909. That's pretty good, especially for a decision tree. So that should already indicate that this particular data set was highly separable, especially if you're getting such good performance off a single decision tree. So you may see a little extra from the RFC or the GBT. We're also using the default, so that's important to remember. You may be able to juice a little more out of the random forest and the gradient boosted trees, but let's explore just with the default arguments or default parameters how well they do. So we'll say now RFC, and I'm going to print, again, my binary eval evaluates, but I'm going to call it on the other ones. So that's RFC, predictions, run this. Okay, so RFC, that's really quite good, 0.97. So you can see here that using just a decision tree is not nearly as good as a random forest. And honestly, it should never really be any other way. It makes sense that having a lot more trees to do the voting or choose the classification would work better than just a single decision tree, especially when you're doing the random splits. So you should always expect random forest to outperform decision tree in almost every situation. Now, something to note before we hit the gradient boosted trees is that gradient boosted trees doesn't actually have the default prediction or raw prediction column. So let's take a look at what GBT preds actually looks like by saying print schema off of this. And you can see here it only has the prediction column. It doesn't have, unlike the other guys, if I call RFC preds and then print the schema, these guys actually had those raw predictions and those probabilities. So that means if I try to pass the predictions into my binary eval, I'm going to get some errors. So let's actually create another evaluator object that expects just a prediction column. Remember we discussed earlier that binary classifier evaluator has no problem using that prediction column instead of the raw prediction. So I will grab this guy, copy it, paste it here, and we'll say my binary eval, and let's label it 2. And what I'm also going to add here is that the prediction column, or I should say this. So remember we need to specify raw prediction column, and instead of raw prediction we're going to specify that it's just prediction. And if you look at the documentation, it specifies that that is okay to do. Okay, so let's make sure those parentheses are balanced. I'm a little zoomed in here, so hopefully that runs well. Okay, perfect. So there's my binary eval 2. so it can take in this prediction column, and we're going to delete that, and then print gradient boosted tree, and print out my binary eval2 evaluate these GBT predictions, or preds. Let's run that. And we can see here this gradient boosted tree did not perform as well as RFC, and also did not perform as well as the decision tree. So that may be surprising to you. And the reason for that is because with the gradient boosted tree, we actually didn't really edit any of the default parameters. And the default parameters that Spark provides to you may not be really good for your particular data set. So what you should do is when you're actually creating the model, come back up here to GBT classifier, and if you hit Shift Tab, you'll notice that you have max depth, max bins, and max information gain. A lot of parameters here to mess around with. So you should definitely check these out, play around with them, and that's kind of an assignment to be left for you. Can you deal with random forest classifier and gradient boosted tree classifier to try to juice a little more performance out of them? Especially with random forest classifier, if you look at the defaults here, the actual number of trees used isn't that high. If you expand on this, they will tell you that it's only 20 trees. That's a pretty low number of trees. It's for this particular case, it's no problem, but a lot of times people use up to 100 or 200 trees on a random forest. Again, it really depends on your particular data set and whether that number of trees makes sense, but number of trees 20, depending on how many entries you have, could be a pretty low number. So it might be fun to try to increase the number of trees here and see if that helps out with our prediction. So let's just actually do that right now since it's easy enough. We'll say number of trees, and I'm going to set this equal to 150. So let's run these again. And we're not going to fit all the data. Instead, we're going to just fit the random forest model, run that. So now that I have 150 trees, it's definitely going to take quite a bit longer than it used to, but that's okay. Now I'm just going to do RFC predictions, run that, and then we'll say from PySpark, run that again. That should still be good, and let's run these again. So that's still 0.909, and this is what we're going to redo. So this is with the 20 trees. Let's see if bringing it to 150 trees increased the accuracy. And there we go. So you can see here that we've already juiced up to 1% as the area under the curve. Not bad, especially since we just had to change the number of trees, and the actual work we had to do was essentially just changing one line of code. All right, so we saw how affecting the parameters of the models can help increase performance, but what I also want to discuss is about our classification evaluators. Right now we're doing binary classification, so we imported the binary classification evaluator, but fortunately, if you want to test things like accuracy, precision, or recall, you can't grab those directly from a binary classification evaluator, but you can grab them from the multi-class classification evaluator directly. And actually Spark plays nicely even if you're just doing binary class, and you can use that as well. So let me walk through how to do this. And there's a more detailed example in the Spark notes, or the notebook that goes with this lecture. We'll say from PySpark.ml.evaluation, and we will import the multi-class classification evaluator. So we'll run that, and then let's create our, we'll say this is an accuracy evaluator, ac-eval. We'll take multi-class classification evaluator, specify that the label column is that private index column from earlier, and then that should actually be it. The prediction column, if you do Shift Tab here, is by default prediction. It's included in all of them, so we'll just run that. And then the next thing we're going to do is actually grab the accuracy. So let's make sure that we're doing accuracy if we do Shift Tab. So the metric name right now is F1, and I'm actually going to copy this and set it to be accuracy. So it can specifically be set to accuracy as a string. And as we mentioned before, you can check out the documentation for all the metrics available. So we will run that this time, and then what we're going to do is evaluate this again. So let's evaluate something like the random forest. We'll say random forest accuracy is equal to this accuracy evaluator, and evaluate on RFC predictions. So that once that's done running, we'll say RFC accuracy, and it's 94% accuracy. And if you want to check other metrics, you can always just replace this metric name with the other available metrics shown in the documentation. As a quick side note, you can check out the notebook for this particular lecture, and I've gone through and shown the accuracy of just using pure defaults on all three models, and they're actually all super similar. They all get about 91.5% accuracy. The one that has the highest accuracy, just with the defaults, is the gradient boosted tree. But again, that may come at the cost of good precision or good recall. So definitely have a lot of fun with this. I want to leave it as an optional assignment for you, but I highly encourage you to just start playing around with the parameters. In these kind of models, it's really useful to see how changing certain parameters can affect the accuracy or performance of the model itself. And if you have questions on some of those parameters, you can do the reading in an introduction to statistical learning to find out more about what each of those parameters actually does. Okay, hope you enjoyed this project. Coming up next, we're going to discuss actually your consulting project for this section of the course. I'll see you there.